There's some information that we need to gather in order to give proper estimates out. So, for example, we had a customer call us, said he was installing a new sign and he knew the amperage, but we need to know the voltage. And there's a difference of voltage and amperage, and I'm going to kind of just quickly explain some of the reasons why we need to know. A lower voltage, it usually ends up using more amperage than a higher voltage. So wire size and all of the costs involved are based on these calculations that we make using Ohm's law as electricians. So in a residential system, you're looking at a single phase, 120/240 is your typical residential system. And what that consists of is two hots, a neutral, and a ground. And then we'll move from a typical residential to like a typical commercial setting. So a typical commercial setting is a three-phase system. Here are the two most common scenarios you'll find in an electrical system for commercial. So we have our 120/208 three-phase, which is a black, it's three conductors, so it's a three lines, A phase, B phase, and C phase, black, red, blue, a neutral, and a ground. And then you'll find 277/480 volt, three-phase, which is a brown, orange, yellow, a neutral, and a ground. There are different colors for the neutrals. In 120/208, your neutral is white, and in the 277/480 volt, your neutral is gray. So if we look at the voltage across the board, on a residential, we got 120/240. What that means is when you test one of your lines to neutral, you're gonna get 120. If you test one of your lines to ground, you're gonna get to 120. For 240 volt, you're gonna test one line to another line. That'll give you 240 volts. So when somebody asks you for I need a 210 outlet, there's really no such thing as a 210 outlet. These are the systems that you run into in America. So when you hear somebody say that they need 210 volt outlet, it's typically, we're gonna round that, they're gonna get 240 volts. So what happens is if the equipment says 210 and it's running at 10 amps, we're gonna provide it with 240 volts. Well, it's gonna run at 8.75 amps because that's just math. Then we've got the same kind of concept in commercial. So black, your A phase to neutral or ground is 120. Same thing with your B phase and your C phase. It will all be 120 to ground and neutral. Phase to phase, any which way you combine that, it's gonna end up being 208. So it's the same scenario here, just a higher voltage. Phases A, B, and C, or your brown, orange, yellow. Those are colors that are required by code. To neutral or ground will be 277. Phase to phase will be 480 volts. Also, you'll see this scenario here where a commercial building will be fed with this. And then we'll use a transformer to create 120/208. So you'll get 480 volt three-phase coming into the building, and then we'll transform down to get 120/208, because this 120/208 is your receptacles. Those are your typical receptacles, the things that you use every day. If you're in a commercial building that has 277/480, it will have 120/208. It will. It's gonna have it. If you have the option to put in equipment at 480 volt or 120, you're gonna wanna choose a more efficient. This is more efficient. A lot of your air conditioners run at 480, a lot more efficient, less amperage, so it's gonna save you money in the long run. Okay, so that's voltage. Now we're gonna talk about amperage. The lowest amperage you can see in a residential setting is 15 amps. And anything commercial has to be 20 amps. So 20 amp is our minimum in a commercial setting, and 15 is at a residential. You'll see a lot of 15s and a lot of 20s. Your dryer and your water heater might be 30 amps, unless you have an Insta-Hot. Then you'll have your oven, your range, your air conditioners will all kind of run in here in this area, 40 to 60. And then your main panel will typically be anywhere from 100 to 200. We see a lot of 200 amp services in the valley here. So that's typical of a residential setting. And then on a commercial setting, we'll start at 20, and then we can go all the way up to thousands of amperage on typical electrical systems. I stopped this at 1,000. It's a round number. It's also significant because that's where you need GFI protection added at that point moving forward. Anything over that, you're gonna need ground fault current interrupter, which a lot of times they take care of that with a GFCI breaker. So now I want to touch on amperage. Amperage is what determines the wire size. So if you have a piece of equipment that needs a 50 amp circuit, it doesn't matter if it's 120, 208, 277/480, it doesn't matter. 50 amps is what we're going to size that wire. And depending on the application, typically we see a number 8 gauge there. But you're going to want to look in your NEC code book, your National Electric Code book, in Chapter 3, Article 310. The amperage varies on temperature, the wire way, the raceway that you're using, what type of wire. So you're going to want to find out exactly what the scenario is to determine that wire size. But when we're estimating, a 12 gauge wire is going to cost reasonably less than, an 8 gauge wire. So we use the gauge of wire to determine what conduit we need to run, what overcurrent protection we need. Do we need to have fuses? There's a lot of things that we need to have sized for that overcurrent protection based on the amperage. So when somebody calls in and says that, hey, we've got a 125, 250 volt, 3-phase circuit that they need, I know that I'm going to end up in the 120, 208 volt 3-phase section. So now what this 125, 250 volt tells me that it needs a neutral, because if without that neutral, we can't get to 120. We can't do that. Everything phase to phase is going to be 208 volt, a higher one. So I know now what I need, how many wires and what kind of wire. I just don't know the size of wires that I'm going to need. So that's when we go, hey, what's the amperage? He's gonna tell me whatever it may be. He's gonna say it's gonna be a 30 amp circuit for a 3-phase air handler. So now I know I gotta use number 10 wire, and based on that, I know what color wire I need. I know what breaker size I need to buy, what disconnect size I need to buy. I know I need to run 3/4 EMT. After finding out the power requirements, voltage, phase, amperage, the only other thing we need to consider, and we'll find this out typically when we do our site visit, is the distance. So distance does play a factor in, so there's a voltage drop, and you need to calculate those things. So the farther we go, the more resistance we need to add. We need to increase the wire size to take the same amount of amperage for longer distances. If I missed anything, feel free to comment and I'll hit it on another video.